Hello, and welcome to our remote learning food safety webinar series. My name is Ashley Skinner, and I will be your host for today's webinar. This series is funded by the USDA and is led by our PI, Dr. Michelle Danieluk from the University of Florida Citrus Research and Education Center located in Lake Alfred, Florida. This project is in collaboration with Florida Agricultural and Mechanical University with PI Dr. Harriet Paul, located in Tallahassee, Florida. Our overall goal with this community outreach project is to develop innovative and engaging remote learning produce food safety curriculum that is highly accessible to diverse growers, particularly small and beginning farmers, in order to equip them with increased food safety awareness and the skills to adopt proven food safety risk reduction practices. To do so, one of our aims is to deliver instructor-led workshop webinars to diverse audiences across Florida and the US. Today, we have some participants from FAMU, which welcome Casey Elder, Taquasha Freeman, Bethany Noel, Jamesia Henderson, Rachel Fernandez, and Joy Adkins. And finally, we have Dr. Abhinav Mishra from the University of Georgia. He is an associate professor in the Department of Food Science and Technology and is our featured presenter to teach us about risk analysis and assessment. Take it away, Dr. Mishra.
Thank you very much, Ashley, for inviting me. It's my pleasure to communicate with everybody who is on this meeting today. And as I understand that everybody is not from a food science, food safety background, feel free to intervene, ask questions while I'm presenting certain topics. If you want to hold the questions till the end, that's also fine with me, but I won't be offended if you intervene in between. So in today's lecture, we will learn about risk analysis and assessment. Basically, we hear about these terms: risk, hazard, risk analysis, risk assessment, HACCP, risk management. And oftentimes these are very confusing. So it's better to have a good understanding of these terminologies so that we can understand the things according to a system approach. We all know that there have been lots of foodborne outbreaks because of bacteria, viruses, parasites, some chemical hazards such as allergens, some toxic chemicals, sometimes physical hazards. So that has been a major risk for the food industry and regulatory agencies as well as consumers. So in the risk analysis approach, what we do is that we try to understand different types of hazards from a farm to table concept. We try to integrate everything that happens before harvest, after harvest, during transportation, distribution, retail, storage, consumer preparation, and finally consumption. We try to integrate everything because that is important to understand the risk as a whole system. I'm going to discuss risk and hazards in a little bit, but just a brief introduction that risk analysis and risk assessment are different. Risk management is different. Basically, risk analysis is an umbrella term which includes risk assessment, risk management, and risk communication. So all these three come under risk analysis. And what these mean, we will discuss in a little bit. Basically, this whole process has to be very transparent so that everybody understands why certain foods and certain hazards have a higher risk as compared to other foods and hazards pair. While doing this risk analysis, we also have to look at the regulatory impact assessment, because let's say if we are talking about a hazard and risk pair, which is not very significant, but if we do a wrong risk assessment, let's say we identify that CBOT is a big problem in leafy greens, which is not the case, then industry has to basically employ or deploy their resources on those unnecessary risks. So we have to very carefully identify which risks and which hazards are relevant to certain foods. We all know that there is a significant impact of foodborne contaminants in terms of different types of bacteria and other types of hazards. So we have to always look at the impact that these hazards have in terms of their illnesses, hospitalizations, deaths, many times some chronic diseases. So we have to look at all of those. And because this is very complex, we need to have structured, very systematic type of risk assessment. So as I promised that we will discuss about risk assessment, management and communication, which are basically part of the risk analysis umbrella. So in risk assessment, we try to understand what is the risk. Is it high or low or medium? Is it significant or is it not significant? So sometimes we do qualitative assessment. If we don't have too much information, we qualify the risk, whether it is high, medium or low. And if we have sufficient data, sufficient information, we try to quantify that. Let's say certain pathogen causes 1 million cases of infections in the US every year. So there are different steps in risk assessment, which we will discuss later. Basically, it includes hazard identification, characterization, exposure assessment, and risk characterization. Rachel, you have any questions?
Yes, I wanted to, can you explain further what HACCP is and how it would relate to the food safety rule that there is already out?
I was actually going to explain that, but that's a great question. So what these 4 steps under risk assessment mean, we will try to understand. That in the next few slides. But for now, just understand that it has 4 steps. After we do risk assessment, which is generally done by the academia, by the regulatory agencies, next comes the topic of risk management. Basically, in risk assessment, we are assessing the risk, we are calculating the risk, quantifying the risk. In risk management, we are trying to somehow mitigate the risk, to bring the risk under control. Who does that? Industry. Let's talk about the example of milk pasteurization. Industry knows that they have to pasteurize at certain temperature for a certain amount of time. So there are different guidelines which are established by the regulatory agencies, and industry tries to follow those. Sometimes they try to find out their own mechanisms to further control the risk, which may be more stringent than the regulatory guidelines. I have a question. How many of you have this term, have heard about HACCP before? Hazard Analysis Critical Control Point. So don't worry if you have not heard about this. HACCP is basically, it has very historical relevance in food safety. Let's go back about 60, 70 years ago when there was USDA, there was FDA, but food safety risks were not evaluated very carefully. We all knew that if we cook the meat, let's say beef patty or some other type of meat, most likely we will kill different types of bacteria, but we did not understand the mechanisms, the factors that affect their growth and inactivation in different types of foods. So in 1960s, NASA wanted to send some food with the astronauts who were going on some space missions. So imagine if somebody is going to space, they will not be having resources that we have, like they will not have any doctors, they will not have any medicines other than what they carry with them, and there may be different types of diseases. So NASA wanted to send the food which would be defect free. And how do we make sure that the food is defect free without testing the food? And we know, I mean, some of you might have taken some microbiology courses, some chemistry courses. most of the tests are destructive tests. Basically, you cannot consume that food after you do those microbial tests, because you will have to mix that food with different types of media and chemicals and things like that. So they wanted to follow a preventive approach rather than reactive approach. So in 1960s, this concept hazard analysis critical control point was for the first time introduced by a company called Pillsbury Company. So basically, if you look at the terms here, hazard analysis, analyze the hazard, what type of hazards can be present in that food. Let's talk about, for example, let's take beef. So we know that there have been outbreaks related to E. coli, Salmonella, sometimes Listeria, Clostridium botulinum, and so on. So we know what types of hazards are there. Then critical control point. Control point means where can we control the hazard? So let's say if we are talking about beef, where can we control the hazard? Mostly by cooking. When we cook the food, in most cases, we are able to inactivate most of the vegetative cells of bacteria. So that is our control point. Critical control point, that means if you don't control it at this step, most likely this hazard is going to make people sick. So that's why it is called critical control point. So in this example, for beef patty, let's say, cooking is our critical control point. So basically we identify the parameters. If we have to cook, what is the minimum temperature at which we have to cook the food? For how long do we have to cook? So there are different guidelines. 165 for certain number of seconds should be the internal temperature of the beef patty so that we can inactivate most of those hazards. So HACCP is one example of risk management tool. HACCP is not entire risk management. It's just very small part. Basically, industry follows the HACCP principles to control those different types of hazards which are relevant, which were identified with our risk assessment activities. There are other risk management tools as well. How many of you have heard about FSMA, Food Safety Modernization Act? FSMA is another risk management tool. Basically, all those foods which are regulated by FDA, most of them, with some exceptions, most of them are regulated under FSMA regulations and not HACCP. Anyway, that's a little bit different topic. Maybe some other time we can discuss that. But risk communication is the third major component of risk analysis. Risk communication, basically, we are communicating about risk. Who communicates? Everybody who is involved. Academia, industry, regulatory agencies, consumers, every stakeholder who is part of this food supply chain is talking about this. If risk assessors, they found out that, hey, this hazard, I found that this hazard is now more significant in this food, then risk management people or the industry people, they will try to control that hazard. This whole communication with regulatory agencies, with consumers, with distributors, that includes risk communication. There are scientific conferences, there are meetings, even classroom teaching is a part of risk communication. Jamesia has some questions.
Yes. So does HACCP cover both the production of food and processing, like in factories?
Yeah. Everything that happens inside the industry is part of risk management. Even on farm, let's say if we have certain criteria for the agricultural water, that is also part of risk management, that we treat the recirculated water or recycled water with certain treatments. That's also part of risk management. Everybody who is handling the food during the supply chain, is risk management. You bring, let's say, a frozen pizza to your home. You have to cook it at certain temperature for certain amount of time. You might have seen that if you have to microwave it for at least 2 minutes. If you are doing oven cooking, keep the temperature for, let's say, 300 Fahrenheit for certain minutes. Those are also part of risk management. You are also managing the risk. So in this lecture, mostly we will cover risk assessment, but we will also touch a little bit on the topic of risk management. So risk assessment has 4 defined steps, which are hazard identification, hazard characterization, exposure assessment, and risk characterization. Don't worry if these terms sound very complicated, very complex to you. You don't have to memorize these terms. But if you understand the concepts, what do we do behind these steps, that is more critical to understand. So you might be seeing Codex Alimentarius Commission. This is the part of WHO. Basically, it has defined this risk assessment framework. So whenever we have to do any risk assessment, we have to follow these steps. Otherwise, it will not be considered structured and acceptable form of risk assessment. All right, so before we move to those 4 steps, let's try to have a clear understanding of these 2 things, risk and hazard. Because many times, if we discussed hazard analysis and critical control point, where was the risk there? So we should understand what is risk and what is hazard, because many times we mix or confuse with these terms. So hazard is basically anything that can have some undesirable outcome or results. Basically any biological, chemical, physical thing that can harm you or that can make you sick in food borne illnesses. Generally, mostly it's illness, which is the undesirable outcome. But sometimes physical hazards, for example, if there is any glass particle, any metal particle, which can also cause different types of injuries. So those are also hazards. But mostly when we talk about risk assessment, because most of the illnesses are from biological hazards, most risk assessments are related to those biological hazards, mostly bacteria, because bacteria are the most notorious pathogens which are present in foods. So hazard is basically anything that has potential to cause that effect. But risk is a more scientific term. Risk is basically a function of probability. Is it likely that this hazard will be present in a certain food? And not only probability, but also the magnitude of that effect. How severe is that hazard? We all know that you might have heard about different viruses like norovirus, for example. Norovirus is present in a lot of agricultural commodities because it is present in water. Norovirus causes a huge amount of recalls in the US market. But any infection related to norovirus does not last more than a couple of days in most cases. And compare that with Clostridium botulinum. If CBOT produces any toxin, it results in large amounts of illnesses, hospitalizations, and in many cases, it results in death. So we have to consider what is the magnitude of the effect. Is it going to cause a couple of days of diarrhea, mild fever, some other mild symptoms? Or is it going to cause a more severe effect? Is it going to cause chronic diseases such as cancer, some other long-term diseases? or is it going to cause the death of the consumer? So risk is basically a combination of both probability as well as the magnitude. Casey has some questions.
Yeah, I just had one question. So I know a lot of different products in agriculture, like manure, are hazardous, but they have other beneficial uses like during production. So how can that farmer be certain that that hazardous material they're using won't cause a risk to their product?
Okay, so if I understood your question correctly, you said there are some hazards in, for example, manure,
Yeah,
but those may be beneficial to the crop, for example.
yeah,
So when we talk about foodborne pathogens, generally we have bacteria like Salmonella, E. coli, which are sometimes present in the manure. And that's why it is important to treat the manure before we apply that, so that we can inactivate most of those hazards. Untreated manure, and it's a very relevant question, untreated manure has resulted in several foodborne outbreaks related to leafy greens, different other types of agricultural commodities. So using manure is good, it is important, but we should treat it. We can use heat treatment or some other form of treatment so that we can inactivate those known hazards that are present in the animal feces and in manure. So
thank you.
risk, if I continue my discussion, risk is basically a function of both likelihood and severity. So hazard is any biological, chemical, or physical agent which has potential to cause any adverse effect. For example, Salmonella, it is present in different varieties of fruits, leafy greens, meats, dairy products, low water activity foods. So this is a hazard. But risk is likelihood. Is it going to be present in that food? I discussed the example of Clostridium botulinum. It is a serious hazard when we talk about meats. But is it a hazard for leafy greens? Maybe not, because CBOT does not like the presence of oxygen. If there is any oxygen, CBOT will not be able to multiply or cause any illnesses. So whereas meats, they have some anaerobic environment. For example, if especially if you have let's say poultry carcass or any type of food which has less amount of oxygen in their inner part or the interior, pathogens like CBOT are more likely in those. Whereas leafy greens, there is plenty of oxygen because you have large surface area. So that's why you may never have heard about any outbreak of Clostridium botulinum related to Roman lettuce, whereas you might have heard about outbreaks of CBOT in meats and E. coli in leafy greens, because E. coli can survive and grow in those leafy greens environments. So risk is not always equal to hazard. That's what we need to understand. So to summarize, risk assessment is a process to evaluate the probability of any hazard and what impact it will have. Many times the impact is in terms of number of foodborne illnesses in the US in a given year. Risk management, I'm going to come, I will let Walker ask his question after I discuss this. So risk management is to try to understand different policy alternatives to control the hazards. So once the risk assessors find out what types of hazards are there, risk managers look at different options they have. So let's say if we have risk of some bacteria, let's say Listeria monocytogenes in milk, we will look at different options. Can we heat the milk at 72 degrees Celsius for 15 seconds? Or can we use some antimicrobial? Can we use refrigeration? What are our options? How can we control that hazard in the food? And risk communication includes the exchange of information between all the stakeholders, which includes risk assessors, managers, regulatory agencies, consumers, retailers, everybody who is involved with that food. Walker, please, what is your question?
Good morning, Doc.
Hey, good morning.
I have a question. It's regarding the previous slide. Do you think it is possible to eliminate all of the pathogens in food, or is there any limit that is allowed?
I think there was some issue with the connection. Can you repeat your question? Was it UV light, or if you can type the question, if there are internet
So
issues.
his question was a little broken up because of the internet, but I think he was asking, on your previous slide, you discussed a little bit about salmonella. And he was saying, like, is it possible to eliminate all of the pathogens in a food? Or is there like an allowable limit, I guess, when you're doing like these risk analyses?
Yeah, so that's a great question, Walker. Basically, when we talk about risk, zero risk is never possible. You can never be certain that there is no hazard in this food. Let me give one example. For listeria, FDA has zero tolerance policy, that if there is even one single cell of listeria in a food, you have to recall that food. You cannot sell it in any market. Now, the limit is you need to collect at least 25 grams of food, and that 25 gram of food sample should not have any listeria in it. Let's say you took 25 gram samples, maybe multiple samples, 25 grams, and you did not find any listeria. From the perspective of USDA or FDA, your sample has passed and you can sell this product. But can you give me a guarantee that even if I take 1,000 pounds of sample and there will not be any listeria cell? Maybe you were lucky that within that 25 grams, there was no listeria. But if you take 1,000 pounds of the sample, there may be some listeria cells. If there was no listeria in 1,000 pounds, maybe 10,000 pounds, you may find one. So zero risk is never possible. Whatever you do, there will always be something more stringent. Then there is a concept of acceptable risk, that this much risk is allowed. For example, for listeria, acceptable risk is zero listeria in 25 grams. If you have anything less than that, that's acceptable. For salmonella, the amount and prevalence is basically, it differs for different types of foods. For example, in poultry, it's okay to have salmonella in 8 out of 51 samples, if I'm correct, 8 or 13. So you can collect different samples and you can have salmonella in certain number of samples out of those. Because we know that salmonella is a known pathogen in raw poultry meat. There is nothing we can do. For Campylobacter, it is even more. Campylobacter is present in at least 50% of the samples. If you take 100 samples from the retail market, uncooked poultry meats, you will find Campy in about 50% of those. So in risk assessment, what we do is that we try to control these hazards, but we try to achieve the zero risk, but zero risk is basically a myth. You can never achieve zero risk. We can only try to improve our food safety situation. Takasha has some questions.
Yes, who is responsible party for conducting a produce safety risk assessment?
Um, so there are different agencies. You might have heard about FDA, USDA, right?
Yes, sir.
Mhm. So they have different jurisdictions. For example, meat and poultry is regulated by USDA. There are some other foods, for example, liquid eggs are regulated by USDA. Most other foods are regulated by the FDA. So for example, if your question was for leafy greens are regulated by the FDA. So either FDA, they have their own scientists, they conduct the risk assessment, or academia, like university professors, they also conduct researches. They get some, let's say, funding from FDA, and they will conduct that risk assessment for FDA. Or sometimes they do these types of researches just because they are interested in these. So these are two major groups of people who conduct these risk assessment studies. There are some third party researchers as well, some private researcher, investigator. They can also conduct risk assessments. That's also possible.
Thank you.
Mhm. All right. So once we know what is the risk, what is hazard, what is risk assessment, management, and communication, uh, let's try to understand how do we define what risk assessment do we have to do. There should be certain information, certain criteria. Otherwise, it's a waste of our resources. So first, we identify the potential issues. Are there very frequent recalls and outbreaks because of certain hazard in a food? Let's say E. coli is a known offender in leafy greens. It's found very frequently. Even recently, there was an outbreak of E. coli related to Roman letters. So once there are any potential issues, we start to think whether we need to do any risk assessment or not. So our prior knowledge, um, if you are a food safety expert, you know what types of hazards are associated with what types of foods. If you are not knowledgeable, try to reach out to somebody who has that knowledge. So they will tell you whether this hazard is significant. Is it worth considering or not? If it is worth considering, then you have two questions. Is there any exposure of this hazard in the food? Yes or no? If there is any exposure, how? For leafy greens, are leafy greens exposed to E. coli? Yes, they are exposed to E. coli before harvest from agricultural water, from wild animals who intrude into the fields, from birds, from different other sources, soil, manure. There are different sources which expose them to this hazard. Is this a potential hazard? If there are any exposures, is that exposure potential? Is it causing large number of foodborne illnesses? Your answer yes or no. Basically, look at the recent list of outbreaks. Did you find E. coli in leafy greens very frequently or not? If your answer is yes to those questions, then ask yourself, is the risk assessment necessary? Will it solve some purpose or not? If your hazard was not very significant or potential, maybe risk assessment is not necessary. Or if somebody has already conducted the risk assessment, then doing another risk assessment is not necessary because you already have that information. But if there was no risk assessment in the last 5 years, maybe it's time to update that previous risk assessment. The next question is it feasible or not? do we have enough information to conduct this risk assessment? Because without information for that hazard in the whole supply chain, you will not be able to conduct this risk assessment. And if your answer is yes to both those, is if risk assessment is necessary and it is feasible, then you start collecting information related to that hazard throughout the supply chain. Try to collect as much information. There may be some survey data that report amount of and levels of E. coli in leafy greens. What are the factors that can result in increase or decrease of E. coli during the supply chain? Maybe are there any temperature abuses? If there is any temperature abuse, do we have information? Then with respect to consumption, do people wash leafy greens before they are consuming it, or they don't wash? Because washing does not eliminate this hazard, but it reduces the number of E. coli's. So all those information related to supply chain have to be collected, and based on that, we start our risk assessment plan. Takasha has some question.
Yes, I wanted to know what this floor chart you're using. Are you guys using data analytics in the supply chain to be able to kind of prevent the risk for exposure to the hazard of the product, the produce?
So
okay, sorry. Yes, sir.
Yeah, follow if you have any other question.
No, I wanted to know, like, for example, this floor chart here, is this being used in data analytics to prevent the risk in the supply chain for the produce? Like,
So,
for example, you have like what if scenarios like this is, for example, this type of flow chart, is it being used in data analytics to assist you guys, assist everyone without, preventing the risk of having contamination?
Yeah. So this flow chart is to make a decision whether is it feasible to conduct a risk assessment, and if it is feasible, is it necessary, first of all. And necessity comes whether this hazard is a potential hazard or not, and if there is any exposure. If there is necessity, is it feasible to conduct that risk assessment? So this flow chart basically gives you a decision. Should I do a risk assessment for this hazard in the food or not? And if I have to conduct a risk assessment, then basically we have to follow those four principles that we are going to discuss in the next few slides: hazard identification, characterization, exposure assessment, and risk characterization. So there are different software which basically do that data analytics for us. There are software like R, MATLAB. There are some software in Microsoft Excel. They are add-ins. So all those resources can be used by researchers to conduct this. But most of this flow chart is basically very simple. It does not require huge amount of data analytics. Basically, your answer is yes or no for most of those questions. And if you find out that you have to do risk assessment, then we follow the four principles of risk assessment that we are going to discuss in the next few slides.
Okay, thank you.
Kristen, you have any questions?
Yes, I did have a question. So like with our produce, I know that we import a lot of different foods. Would the risk assessment be conducted just once those products are imported into the United States, or do we rely on other countries to do this risk assessment, and then we go based on their standards as well?
So risk assessment does not interfere with any of the processes. So if we produce any food in the United States, we just collect the information from the US. We try to assess the risk. What is the risk for this food that is produced in the US? If we are importing any food from any other country, we are just collecting the data. What is the number of hazard in the food that we are importing. We can maybe compare the two, the risk from the US produced food compared to the imported food. And then it is the responsibility of the risk managers to make decisions. Should we have any regulations for the imported food? Should we stop importing the foods? Should we take any other decision to control the risk? So that's the under the jurisdiction of risk managers.
Okay, thank you.
But you guys are asking great questions. So once we have come to a conclusion that we have a risk in this food and it is feasible and it is necessary to conduct this risk assessment, we basically formulated the problem, what is the hazard and what is the food, basically that hazard food pair. Then if you remember, there are 4 principles: hazard identification, hazard characterization, exposure assessment, and risk characterization. So what we do in those 4 steps: hazard identification, basically find out if this hazard is causing significant number of adverse health effects, number of illnesses. Those information can be from human studies, from different other types of scientific literature. Another major source can be number of outbreaks from the CDC website, how many people are getting sick. Basically confirm that this hazard is a serious hazard in this food. This is more data driven. You look at the real number of infections in the last few years. After hazard identification, we do hazard characterization. So basically, if this hazard is present in the food, what effects does it have? Any dose response. Basically, if I'm consuming 100 cells of E. coli, what is the likelihood that I will become sick? And if I become sick, what will be the magnitude? Is it going to cause any short-term diseases or any chronic or long-term diseases? Sometimes there is also variability, because I consume 100 cells and some other person consumes 100 cells. Both will have different types of impacts. Somebody may show a lot of symptoms, somebody may be completely asymptomatic, and the third person can be hospitalized. So those types of variabilities are there in terms of how this hazard is going to cause its effect. Then exposure assessment, basically try to find out what is the exposure of this hazard in the consumers. Like if I'm consuming 100 grams of leafy greens every day, and that leafy green is likely going to be contaminated, how many cells of leafy greens am I consuming? Because that exposure is going to decide what is the characterization of this hazard. If I'm consuming lots of E. coli cells, then my probability of illness is going to be affected. So basically, I did hazard identification, confirmed that this hazard is significant. Hazard characterization, basically dose response model. What is the likelihood that I'm going to become sick after consuming certain number of dose of that pathogen? Exposure, I look at the amount of bacteria that is present in the food at the time of consumption. And risk characterization, basically I combine exposure assessment and hazard characterization. Basically calculate the number of cells, and based on those cells, what is the likelihood that I'm going to become sick. And this calculation is basically probability based. There is, let's say, 40% chance that consumer A is going to be sick, 50% chance that consumer B is going to be sick. So we do these types of calculations several thousand times. And based on that, we try to understand the variability. That's very much data driven. Don't worry if you are not too much into probability. Basically, in simple terms, we are trying to calculate how many people are going to be sick or infected with that hazard if they are consuming that particular food. So just to summarize, hazard identification, you identify the biological or chemical or physical agents that are going to cause any infection or illness. Sometimes if information is not there, we also reach out to some experts who have extensive experience in that particular area. In hazard characterization, we do dose response model. So we determine the relationship between the number of bacteria that we are consuming to the severity and probability of those adverse health effects. So there are dose response models. For example, if you are consuming only 10 cells, you may have only 5% probability of infection. But if you are consuming 10,000 cells, you might have 85% probability of infection. So there are dose response models which calculate the probability if for a given number of cells that you are consuming. Exposure assessment, you try to calculate how much exposure do we have, how many number of bacteria are you going to consume, and that is also probability based. Some people might be consuming 100 grams of leafy greens every day. Some other people might not be consuming at all, and somebody might be consuming only 10 grams of leafy greens every day. So based on those probabilities, we basically combine all the information and summarize that in risk characterization. So sometimes if you don't have data, you only have qualitative information, low, medium, high, significant, non-significant. So those types of qualitative risk assessment is also done. And if you have numbers which are more reliable, you do quantitative estimation of the probability of occurrence and severity. And based on that, we calculate how much is the risk or what is the total number of infections in a given population in a year or so. So the decisions about hazards, these are basically very important to control or reduce or eliminate these hazards. And somebody had previously asked that question, that what is the limit that we should accept or we should not accept certain food. So first of all, you should know that zero risk is never possible. There is always some risk. The risk can be close to zero, but cannot be zero. So we are always trying to improve our food safety situation, but many times we accept that certain number of bacteria will be present in the food. Then we make some risk management decisions to limit those number of bacterial cells. So in the industry and regulatory agencies, when we talk about risk, there is always a term called acceptable or tolerable level of risk. For example, for Listeria, we have zero tolerance. That means in 25 grams, there should not be any Listeria. But for Salmonella, we do not have zero tolerance for Salmonella in chicken because we know that it is going to be present. All we can do is try to control that Salmonella, basically cook the chicken meat properly at appropriate temperatures. Because if you are undercooking it, you have the risk of high number of Salmonella cells in the food. So this is a kind of pyramid view of how we conduct the risk analysis, how we control the risk to the acceptable levels. So you will see that this pyramid has kind of 4 components. At the bottom, we have good agricultural practices, good hygiene practices, good manufacturing practices, and so on. Basically, all those food safety, whatever food safety culture we are talking about, is based on this good agricultural GHP and GMPs. If you don't have these, you can't achieve your food safety objectives. Basically, you can't make a food in a dumping ground and think that some risk assessors or some risk managers are going to control those hazards. These are the backbone or the foundation of your food safety culture. Once you have your good agricultural practices and GMPs, then your HACCP or other type of food safety plans or risk management practices, they control these hazards. So these are operational level or things that industry does. Regulatory agencies don't play a major role in these 2 steps. What does the regulatory agencies do? They can't go to every plant every day and see that they are cooking the food at certain temperatures. They do inspections, but those are once in a while. They don't do it on a daily basis. Regulatory agencies or government, they make policies. Basically, some risk assessors, they conduct risk assessment, tell the regulatory agencies that basically this is the current level of risk in this food, and based on that these regulatory agencies, they set public health goals that in the next 10 years we should not have more than 1,000 cases of E. coli in the US population, and or so on. So they set their public health goals, and based on that they instruct the industry to follow certain guidelines to limit those hazards to certain numbers. And in the intersection of this government level and operational level, you see some terminologies: FSO, PO, PC. What are these? FSO is food safety objective, PO is performance objective, and PC is performance criteria or criterion. So let's try to, that's how the regulatory agencies and the industry, they communicate. If you show a risk assessment model to some sanitation crew in an industry, most likely they are not going to understand it. So you have to speak in a language that they understand. So basically FSO, PO, and PC are those languages. I'm going to discuss this food safety objective and performance objective in the next slide. But first try to understand, how do we calculate? We want to limit the number of bacteria or hazard in a food. So where are those hazards coming from? So there may be some initial contamination. Maybe if you are talking about leafy greens, there may be some E. coli when these were harvested. You did not do anything. There may be some reductions. Maybe you are using some antimicrobials or cooking or some other process to kill those bacteria. And there may be some increase, maybe temperature abuse or some unfortunate accident that increased the number of bacteria. So performance objective and food safety objective is the upper limit of bacteria that you can have in a food at a given amount of time. So let's say FDA told you that you should not have more than 10 CFU or cells of bacteria while the consumer is consuming it or they are purchasing it. So if that 10 cells per gram, is your criteria, then your initial population minus reduction plus increase should always be less than that number. Now let's try to understand what is performance objective and food safety objective, because these are important terminologies used in the industry. So we look at the whole supply chain, look at all these steps. So starting from production to manufacturing, transportation, preparation, cooking, and consumption, these are typical steps in the supply chain. So first of all, food safety objective. It is the maximum frequency or concentration of bacteria at the time of consumption. Basically, it defines how much risk do we have in the food when we are consuming it. So that's the ultimate objective. But to achieve food safety objective, you have different performance objectives. So for each of those steps, we decide some criteria that there should be, we define the maximum frequency or concentration of bacteria in that food at that particular level. For example, at retail, we may define some number that for the retail food, retail storage, it should not have certain number of bacteria at that particular step. And in order to achieve those performance objectives, there are some other parameters. For example, if you want to achieve performance objective, there are some control measures that you need to cook the food at certain temperature for certain time. You need to use these antimicrobials to achieve those performance objectives. So those are our control measures. Because, for example, a common employee may not understand performance objective and food safety objectives. He only understands the temperature, that this is my chicken meat and I have to cook it at 165 degrees Fahrenheit for 5 seconds. He understands only that language. He may not have enough training to understand food safety and performance objectives. So finally, just to give you an idea how we conduct risk assessment, if we are talking about sausage, let's say how much is the prevalence and concentration of sausage in animal, in their feces, in their meat. When we do post slaughter or post harvest, we factor for any contamination from the feces to the meat, from other food contact surfaces to the meat, and how much meat do we have in the sausage. Then are there any reductions during production, any cooking, any antimicrobials, any reduction during storage, any increase during storage if there is any temperature abuse, and at the time of consumption, how much are we consuming the food. And based on that, we calculate how many bacterial cells are there. And from the dose response model, we calculate what is the probability of illness. And we calculate that probability for, let's say, 100,000 people, and calculate how many people might be getting sick if all the information that we have is correct. All right, so now the floor is open for any questions. And always feel free to reach out to me via emails.
Thank you so much, Dr. Abhinav Mishra.
No problem, Ashley. It's my pleasure to be here. And I'm very happy that students, they asked lots of good questions.
Mhm.
They made it much more interactive.
Absolutely. They were engaged and, they were asking questions of things that I was like, oh, that's a good question. I wonder what he's going to say. So grateful to have you today, all the way from University of Georgia. So thank you so much for participating in this instructor-led webinar.
My pleasure.